Hey everyone, welcome to my talk about the art of platform engineering. My name is Max Körbächer. I'm co-founder of Liquid Reply, and I'm responsible within Liquid Reply for the cloud native engineering, building platforms on Kubernetes, around Kubernetes, and multi-cloud, hybrid cloud, and on-prem. I'm also part of the Kubernetes release team and release engineering team. Today we're talking about platforms, and platforms is, I would say, a new coming thing. I mean, the term is quite old, but talking about platforms, we mean internal development platforms, application platforms, and so on. What they actually try to do is to abstract away the complexity of the infrastructure provider. Even though it's a cloud, it's still getting quite complex nowadays. But this brings its own new questions into the game. Who's responsible for the application delivery? How many clusters do we need? Which open source tool to use, or do we need to buy something? So today will be about some of the do's and don'ts which we learned when we built platforms. Number one, don't get lost in open source. And this is a very easy one. I love open source. It is awesome. There are tons of tools, hundreds of tools. But this is on the other side also a big problem. If you're looking on the cloud native computing foundation landscape about open source, it's maybe cover around 30% what's available on the market. And it's actually provide somehow, maybe, an answer to all of the questions. But don't get lost there, because there's so many things which you can try out and work on, but really look on what you need. Because the open source market tend to solve exactly one problem with one solution. But there are also multiple solutions which cover a huge, big market or a lot of problems. If you don't need them, do not go for them, because sometimes they have some drawbacks which are in the first line not visible, but come with a really long tail where you need to cover it somehow. Keep it short and easy. Keep your network simple. And actually, this topic alone would require to have a few talks about it. So I try to keep it really simple at this point in time. Most enterprise networks are massively over-engineered. And this causes that in some bad cases, you need to run through multiple firewalls, actually filtering all the time the same, having some proxies here and there, maybe netting and so on. The downside of it is that when you think from a developer perspective, whom you actually want to support as a platform, and where you want to bring maybe some useful tools into the game, you need to route them all through whole the network until they reach your platform. And also on the other hand side, if you want to expose the workload on your platforms to the internet or to the internal client somewhere, you have to consider that some of the open source tools which you want to use to configure the network configuration will not work anymore. So take a look that you can utilize some declarative-free approaches here, or use as much as possible software-defined network. We have it in the vSphere coming with you. If you build on-prem, which is smoothly integrating also into your environment of Kubernetes cluster, for example. But also when you're going to a cloud provider, you have a couple of options, obviously, to manage your network like you do with the software. Don't focus too much on the provisioning of Kubernetes. And yes, that's where a lot of teams actually spend many time to really work on. How do I provision Kubernetes? How to install the cluster here? What I need to configure? The good message is it's not 2018 anymore. You don't have to write your own scripts, your own Ansible stuff for somehow install Kubernetes. If you're running on a cloud, just use the managed service. They are for many, many use cases actually a perfect solution. And meanwhile, they are so flexible that you can also do a lot of adjustments here, breaking it down to a most secure configuration possible you can think of, and also supporting some more crazy use cases. So there's just a small percentile which you cannot solve with the managed service. On-prem, build on what you know. I can recommend you that if you have built on hardware already, that you can really go for utilize what you know there. There are some awesome open source tools like Tinkerbell, but what is even more great when you're thinking about on-prem, you most likely have already a hypervisor running. And we will come back into this for a few seconds. My favorite, just in case, if you want to go crazy and wild, are actually additional control planes on top of what you have built so far. So you can utilize with cross-plane APIs on various cloud provider, on hypervisor, and also integrate further tools to orchestrate actually your orchestration tools. On-prem, I really love to work here with VMware Tanzu because it's actually integrated in your vSphere and it comes up with all the needed tools and critical tools for running your Kubernetes cluster. Start early with the cost management. And yes, you need to really have a look on it. You can really easily start by giving the right tagging in the beginning and the easy naming conventions. Don't go too crazy with naming conventions. We have seen some stuff which like 180, 200 signs long. No one can understand it anymore. And look for first small tools or policies to manage your resources and especially set up alerts for various limits. You can have something like Cloud Custodian, for example, as a basic framework to get the things up and running. When your platform grows and getting bigger and more utilized, we always take a look that we can approach the whole organization thinking about FinOps, because this is not about pure cost management or cost engineering, but also explaining the organization and work with the organization together. What is the best approach to tackle all the costs? And here, in the end, you can also utilize some great tools for managing the costs, like Cloud Health. So you can really dig down onto the single application on a single product, understand where it causes which amount of resource utilization. And for this, you need a really good tagging. That's why it's important you start early with it. And you can make a one-to-one mapping between applications, products, business units, also when they are scaling. And the best thing on it is you can add also a small markup. So you get your work also as a platform team somehow paid. The platforms you're building are for end products or applications. And this is sometimes forgotten that you actually build this platform not just for yourself. You really build it for a team which needs to provide some kind of business value to an end customer. And you need to support them. You even need to ask you the question, if you want to deliver or provide basically the application delivery. This can be simple endpoints like container registry where someone can throw a container onto it, but this can be also a whole source to image pipeline with some integrity checks and hashes, for example. But don't get too crazy also. Just focus on what is important. Most often, the most simplest solution helps in the beginning. Like I said, a container registry. And then when you're working with the teams together, you can identify what they really need. Do they need some further input? Do they want to look on or work on some SLO topics and get a direct feedback loop? Or what is the approach of the teams? For me, what is most important is that I do not disrupt them in their mission, whatever mission they have. But what is clear is that their mission is absolutely not to learn a couple of cloud providers or how does Kubernetes works, how do I configure the Helm correctly and make sidecar injections and all this fancy cool stuff. This is nothing what a developer would like to work on. They want to bring the business functionality and deploy it. So it's our job to make it easy. And there are tons of nice open source tools on the market, which basically supports this approach. And they integrate very well. They integrate with a vSphere environment, they integrate with a cloud or infrastructure as a service environment, because the common language is not the virtualization layer of it, but the Kubernetes which is run there. And that's very beneficial if you can get some of these tools integrated. Multi-clusters and multi-tenancy. I would say it's the most challenging part overall. And it's also, well, not so easy to answer because there are actually two main questions standing in the room. The first one is, how many clusters do I need? a single cluster per application, or do I want to have a shared one just per domain, or what is the right cut? On the other hand side, how do I isolate the workload and also the user? Is it secure? Do I really need it? And these questions actually cause a triangle of three topics which playing and interact with each other. So there is no right and wrong when you discuss about the amount of clusters. I have with my co-founder a continuous discussion about multi or single cluster. But where we are sure in it is if you can easily deal with the automation to provide clusters, you do not make too many custom scripts and focus more on utilizing APIs or declarative-free configurations, like through cross-plane environment. And you always keep in mind it should be easy to use for your end user. Then you're already on the right way, and it doesn't matter if your cluster is a few thousand nodes big or if you have 20 clusters, each per application. On the other hand side, you have always this balance between workload isolation and multi-tenancy, because if one of both is done wrong, you actually don't need to do the other one really well. So better you're good with both parts. The workload isolation knows 3 levels, from Linux container to VM-based containers. And you really would like to live in this VMware or VM-based container environment if you're looking for security. But if not, then sandbox containers are maybe fine enough. And on the other hand side, you need to steer how to access actually the container. You have need to go with a good identity and access management solution. So long story short, building platforms can be very hard, but it makes also a lot of fun. But really do not look for reinvent the wheel. We come already over this top of the mountain. You can utilize what is there and maybe adjust what you need to do. Keep the things easy and look that it's really hands-on solution. And build your platforms for change. Whenever you build a platform, it's not nailed in stone. It will change because the open source environment, the infrastructure, the service provider, cloud provider, the commercial tools will continuously evolve. And always think about your end user. They are not a 5-year Kubernetes veteran, have built all kinds of Kubernetes all around the globe. Thank you very much. Let's get connected.